we are not using. AC ammeters we are not using. So this is our today's outcome. If possible, we may complete these 4 topics in this hour. So this is thermocouple type RF ammeter. Yesterday, I'm explaining this particular as some introduction. Any one of you, any idea regarding this thermocouple type RF ammeter? Thermocouple type RF ammeter. Any idea?
Heat transfer, sir. Heat transfer between two metals.
Yeah, which is used to transfer the energy or heat or electrons from one metal to another metal. So from that, here I'm one more time I'm giving. This is one type of metal. This is another type of metal. See here, this is one type of metal. Of course, this is another type of metal. So these two metals are joined here. This particular one is nothing but junction. This is metal 1 and this is metal 2. So these two are joined. Here I am applying some temperature. This temperature is constant. With this temperature, this metal gets some heat. This metal is also get some heat. So depending upon the properties of these two metals, these two metals may get some different heats. Of course, according to our assumption, this metal gets very high temperature and compared to that metal, it may get low temperature. From that, these two are joined here at this junction. So from high temperature end to the low temperature end, heat transfers. So this flow is nothing but we call that as current generally. That flow we call that as current. And here, of course, here I am connected a D arsenal meter. Here I am connected a D arsenal meter. So this meter is used to measure that particular. So previously, voltage is nothing but we are connected like this. This is positive and this is negative. But current is nothing but which is used to calculate only at the positive. Of course, this is positive. Here we are connecting one ammeter. Otherwise, this is negative. Here we are connecting one ammeter. Can we can we connect the ammeter here between positive and negative? Say yes or no. In between positive and negative, connect any ammeter. Is it possible to measure current
No,
between two terminals? No. టూ టెర్మినల్స్ మధ్యలో కరెంట్ ఇప్పుడు కూడా క్యాలిక్యులేట్ చేయం. చేస్తే ఇమీడియట్ గా మీటర్ ఏమవుతుందంటే ట్రాష్ అవుతుంది. Why? Because here we are connected a shunt resistance instead of series resistance. In voltmeter we are connecting series resistance, and in ammeter for protecting purpose we are connecting shunt resistance. ఎప్పుడైతే మీరు ప్యారలల్ లో కనెక్ట్ చేసారో ఇమీడియట్ గా ఆ షంట్ రెసిస్టెన్స్ అనేది ట్రాష్ అవుతుంది. నథింగ్ బట్ హెవీ లోడ్ తీసుకుంటుంది. దట్ హెవీ లోడ్ గివ్స్ దట్ ఫుల్ స్కేల్ డిఫ్లెక్షన్ యాజ్ మాక్సిమం ఆర్ ఇన్ఫినైట్. With that, automatically in that point, in that meter there is a winding. That winding may destroys the complete meter. So this is nothing but the flow of current. How that flow of current will be achieved by using this thermocouple type RF ammeter. So thermo is nothing but temperature. A couple is nothing but connecting. Thermocouple nothing but by using temperature we are connecting the two dissimilar metals. This is for to achieve RF type ammeter. Why we call this as RF? Because of this type of ammeters are used for RF applications. Radio frequency range తెలుసు కదా అందరికి. Any one of you, what is the range of that RF frequency? What is the range of that RF frequency? AF frequency range AF frequency range.
RF 20 kHz to 300, sir. 300 GHz.
So AF equals to 20 Hz to 20 kHz.
20 kHz. Yes, sir.
RF equals to
20 kHz to 300 GHz.
20 kHz to. So this is the range. RF frequencies we are using. So that's why this meter is able to operate under such conditions. So that's why we call that as RF ammeter. See here, these four are the four different types of thermocouple type ammeters. These four are the four different types of thermocouples. The first one is mutual type RF ammeter. So mutual type RF ammeter is nothing but, see here, it's a thermocouple. Thermocouple nothing but two metals or one metal. Thermocouple is nothing but there we are connected two metals or one metal.
Two metals.
Yeah, simple. Thermocouple is nothing but the combination of two dissimilar metals. So this is thermocouple. That means here in this metal, heat will be transferred from one to other. That means here already what we are concluded previously in the last slide. ఈ స్లైడ్ లో మనం ఏదైతే చెప్పుకున్నామో the total will completed here. The total energies are completed here. The total is completed here. That means this is ready to give some transfer of heat. So which is connected to 1 meter. 1 meter. So from here to here, automatically those energies transfers in this direction and which is recorded here. So this meter just through this junction. Of course, this particular area is nothing but junction. This particular area is nothing but junction, and that junction change of heat or change of currents will transfer from here to here. So that is recorded here. So next one is a contact type. So mutual type is nothing but directly we are giving that particular junctioned heat or junction currents to the meter. That contact type is nothing but here we are taking one more contact to add this. See here, this is thermocouple element and this is heater. This particular one is heater. That means from this heater we are applying heat to this thermocouple. From this heater to we are applying heat to this thermocouple element. That means this heat is not directly proportionated by the thermocouple. Here we are connecting or we are contacting one more heating element to thermocouple. That means the thermocouple heat proportional to the heater. So which is based on this contact. So this is nothing but high end of energy. Why? Because it's a mutual or direct contact type. This is second one, nothing but heater type. ఏదైనా ఒక పర్టికులర్ ఎలిమెంట్ ని మనం డైరెక్ట్ గా ఫ్లేమ్ లో వేసాం అనుకోండి, ఏదైనా ఒక పర్టికులర్ డైరెక్ట్ గా ఫ్లేమ్ లో వేస్తే ఈజీగా బర్న్ అవుతుంది. దాన్ని ఏదైనా ఒక పర్టికులర్ కేసింగ్ లో పెట్టి ఫ్లేమ్ లో వేసాం అనుకోండి, ఫస్ట్ ఏదైతే ఉందో అది బర్న్ అయిన తర్వాత మీరు పెట్టిన కంటెంట్ అనేది బర్న్ అవుతుంది. అంటే ఫర్ ఎగ్జాంపుల్ డైరెక్ట్ గా వాటర్ ని ఫ్లేమ్ లో పోసాం అనుకోండి, ఈజీగా వ్యాపరేట్ అవుతాయి. అదే దాన్ని ఒక డిష్ లో పెట్టేసి కింద ఫ్లేమ్ పెట్టాం అనుకోండి, ఫస్ట్ మీరు పెట్టిన డిష్ అనేది హీట్ అవ్వాలి, దెన్ water heat అవ్వాలి. So that is nothing but contact type. That means first you are apply temperature to this heater. So this heater may get sufficient heat, then which heats the thermocouple element. Then it gives that ammeter. But here this is direct type, nothing but mutually these two are connected. If is there any variation in this which is transferred to this thermocouple, that means this is low end area and this is high end area. This is low end area and this is high end area. So these two are mutually connected. But here this is contact type. That means here we are connecting one to the other. But here, which is only the heater. This is not heater. This thermocouple is not heater. So heating element is the heater. So which is heated the thermocouple. Then that particular transfer to this ammeter. So this is nothing but a contact type. So third one, separate heater type. So here also the same diagram, but here we are using some glass bead here. Glass bead. See here, this is glass bead. Glass is which type of material? Conductor or semiconductor or insulator? Glass. Glass conductor, semiconductor, insulator.
Semiconductor, sir.
Bead is nothing but what? Bead. In Telugu, that bead is nothing but పూస. పూస అంటారు. చిన్న చిన్న పూసలు ఉంటాయి. పూస అంటారు. జనరల్ గా గర్ల్స్ యూజ్ చేస్తూ ఉంటారు ఆ పూసల్ని. అమ్మవాళ్ళు మదర్ వాళ్ళు నల్ల పూసలు అంటారు, చూసే ఉంటారు. చిన్న చిన్నగా బ్లాక్ కలర్ లో చిన్న చిన్నగా ఉంటాయి, నల్ల పూసలు అంటారు. నల్ల పూసలు దండలు అని చెప్పేసి అని అమ్మవాళ్ళు వేసుకుంటూ ఉంటారు. దట్ ఈస్ నథింగ్ బట్ బీడ్. బీడ్ పూస అంటాం తెలుగులో దాన్ని. సో గ్లాస్ bead is nothing but glass పూస అన్నమాట. So that is nothing but pure semiconductor. So here this is used to transfer the heat in this direction. But here we are used one contact nothing but separate heating. That means, so this is previously in contact type, this heater connected to thermocouple. This is thermocouple. So previously this heater is directly connected to this thermocouple, and this is now this glass bead is connected in between these two. That means from heater to glass bead, then glass bead to thermocouple. That means it may take some time. For transferring the heats from heater to the thermocouple. So initially directly thermocouple connected to ammeter, later thermocouple connected to ammeter, but heat is from the heater. A third condition, thermocouple connected to the heater with a glass bead. That means it may take some slow compared to the previous two. So here this is nothing but glass bead, and this is the condition for to get the minimum currents. If here you were connected a insulator instead of glass, you connected a insulator. Of course, it may take maximum time for the heat transfer. జనరల్ గా మీరు నేను ఎగ్జాంపుల్ చెప్పాను, ఒక ఐరన్ బాక్స్ తీసుకుంటే ఐరన్ బాక్స్ లో ఒక ఫిలమెంట్ ఉంటుంది. ఆ ఫిలమెంట్ ని కింద ఐరన్ బాడీ మీద ప్లేస్ చేసి ఉంటుంది. డైరెక్ట్ గా ఫిలమెంట్ కి మనం పవర్ ని కనెక్ట్ చేస్తాం. బట్ ఆ ఫిలమెంట్ ని కనుక డైరెక్ట్ గా కింద ఐరన్ బాడీ కనెక్ట్ చేసాం అనుకోండి, ఫిలమెంట్ డైరెక్ట్ గా పవర్ వస్తుంది కాబట్టి ఫిలమెంట్ ని పట్టుకుంటే షాక్ కొడుతుంది. డైరెక్ట్ గా ఫిలమెంట్ ని ఐరన్ బాడీ కనెక్ట్ చేస్తే ఐరన్ చేసేటప్పుడు మీకు ఐరన్ చేతికి తగిలింది అనుకోండి, మీకు కూడా షాక్ కొడుతుంది. లేదా ఐరన్ చేసేటప్పుడు వాటర్ యూజ్ చేస్తారు, ఆ వాటర్ తో కూడా మీకు షాక్ కొడుతుంది. అందుకే ఏం చేస్తారంటే ఫిలమెంట్ కి అండ్ ఐరన్ బాడీకి మధ్యలో ఒక ఇన్సులేటర్ మెటీరియల్ యూజ్ చేస్తారు. ఇన్సులేటివ్ మెటీరియల్ యూజ్ చేస్తారు. యాక్చువల్లీ నేమ్ కరెక్ట్ గుర్తులేదు నాకు. ఒక మెటీరియల్ యూజ్ చేస్తారు. దట్ మెటీరియల్ ఈస్ ఎలక్ట్రికల్లీ ప్రూఫ్, బట్ విచ్ ఈస్ నాట్ హీట్ ప్రూఫ్, which is electrical proof only. And that means from filament to the iron body, which gives the heat but which opposes the current. That current is nothing but electric shock. So automatically a filament నుంచి వచ్చిన heat మొత్తం iron body కి ట్రాన్స్ఫర్ అవుతుంది. అంటే heat మాత్రం ఆగదు, but just which opposes that electric shock. ఇన్ కేస్ రెగ్యులర్ గా ఏమవుతుందంటే మనం యూజ్ చేసి కొన్ని ఇయర్స్ తర్వాత ఆ ఫిలమెంట్ కి అండ్ ఐరన్ బాడీకి మధ్యలో ఉన్న ఆ పర్టికులర్ ఎలక్ట్రికల్ ఐసోలేషన్ అనేది మెల్లగా డిజాల్వ్ అవుతూ ఉంటుంది. అలా అది ఏ ఏరియాలో అయితే డిజాల్వ్ అయిందో, ఒక పర్టికులర్ ఏరియాలో డిజాల్వ్ అయిన ఐరన్ బాడీ మొత్తం ఆ పర్టికులర్ ఐరన్ బాడీ మొత్తం షాక్ వస్తుంది. జనరల్ గా మనం ఆ పర్టికులర్ కండిషన్ లో షాక్ వస్తుంది ఐరన్ చేసేటప్పుడు అని చెప్పేసి తీసుకెళ్ళాం అనుకోండి, అది సింపుల్ గా ఏం చేస్తాడంటే రెండింటికి మధ్యలో ఒక చిన్న షీట్ ఉంటుంది. ఆ షీట్ కూడా మీ ఐరన్ బాక్స్ ఏ షేప్ లో అయితే ఉందో ఆ షేప్ లోనే ఉండాలి. ఇన్ కేస్ ఆ షేప్ కనుక లేదనుకోండి, ఆ షేప్ ప్రకారం దాన్ని మనం కట్ చేసుకోవాల్సి వస్తుంది. మీ ఇంట్లో కనుక ఐరన్ బాక్స్ ఉంటే ఇమీడియట్ గా ఓపెన్ చేసి చూడండి. ఇమీడియట్ గా అంటే క్లాస్ అయిన తర్వాత రెండింటికి మధ్యలో ఒక షీట్ ఉంటుంది. మీరు ఆ షీట్ కనుక పాడైపోయిందని చెప్పి డైరెక్ట్ కనెక్ట్ చేశారనుకోండి, ఆన్ చేయగానే ఐరన్ బాడీ మొత్తం పవర్ వచ్చేస్తుంది. So that is nothing but to maintain the isolation between filament 2 like that. Just here also we are connecting one glass bead for to maintain some isolation from heater to thermocouple. So that is nothing but to maintain some distance from heater to the thermocouple. So coming to this fourth one, bridge type. So it is completely extend one. So this is one thermocouple, another thermocouple. So four thermocouples were connected here. These four are recorded here by meter. So the here Hughes currents are for this. Hughes currents. ఇక్కడ ఈ బ్రిడ్జ్ కనెక్ట్ చేసాం కాబట్టి సో ఇది ఒక థర్మోకపుల్ ఇది ఒక థర్మోకపుల్ దీస్ ఆర్ ఆల్ థర్మోకపుల్ జస్ట్ అబ్జర్వ్ హియర్ ఆల్ దీస్ ఆర్ పాజిటివ్స్ వై బికాస్ దిస్ ఈస్ కరెంట్ if it is voltage you need plus and minus if it is current you need only positive or negative just these two terminals only so this is nothing but different types of thermocouples here we have four types of thermocouples mutual type contact type separate heater type bridge type thermocouple mutual type contact type separate heater type and bridge type thermocouple these four now are this is this is clear.
Yes, sir.
Yes, sir.
Okay, ma. Thank you. So these are the advantages. Please note down these diagrams. Please make it fast. Please note down this diagram. Make it fast. Clearly చూడండి here directly connected here connected through heater here connected to heater but isolation is glass bead here this is bridge type so different to the remaining three. Completed. Yeah. See here, these are the advantages. So parallelly, please note down. Thermocouples are cheaper than the resistance thermometers. These instruments are not affected by stray magnetic fields. These instruments are free from frequency errors. Of course, we are not using that. These instruments have high sensitivity. The temperature is nothing but sensitive. These are very useful when used as transfer instruments to calibrate DC instruments by potentiometers. So resistances are more accurate for temperature because of its temperature coefficient effects. Disadvantages, they have lower accuracy and cannot be used for precision work. So temperature nothing but of course in some conditions atmospheric conditions also takes place. So that's why its accuracy may vary. To ensure long life of thermocouples in their operating environments, this is somewhat typical. Why? Because a device which is operated with temperature, its life is very less. They should be protected in and open or closed end metal protecting tube. Just for that, just you have to you want to protect, you have to keep it in metal protecting tube or closed or closed. If it is closed, okay. Otherwise, in open, you have to protect it from the protecting devices. So these are the advantages and disadvantages of thermocouple type RF ammeters. Clear? Just note down. Roughly, please note down that. Okay, ma. Next one, ohmmeter series type. Ohmmeter series type. See here, here I want to know something. If a circuit is open circuited, so this is of course what about these three parameters? If a circuit is open circuited, here I am giving some voltage. What about the voltage here? In this circuit, what about the voltage? Maximum or minimum?
Maximum, sir.
So voltage maximum. What about the current?
Minimum, sir.
Resistance?
Maximum, sir.
Maximum. In other hand, a circuit is short circuited. So this is short circuited. So what about the voltage?
Just opposite all, sir.
So that is minimum here, maximum here, and minimum here. Here just I want to take only among these three parameters only one parameter, that is resistance. So in open circuit resistance infinite and in short circuit resistance 0. Please note down that particular. In open circuit resistance infinite. In short circuit resistance equals to 0. Infinite and 0. So here I'm taking 1 meter. Of course, this is 1 meter. Whatever it may be that. This is its scale. So these two are its patch cords. This is positive and this is negative. So these two are not connected. Means what? These
Open
two
circuit.
are not connected. Means what? Open circuited or short circuited?
Open circuited, sir.
So it's open circuited. So in this condition, what about the resistance?
Maximum, infinity, sir.
Infinite. In second condition of meter, so this is positive and this is negative. So these two are connected. What about the resistance here?
0, sir.
0. Generally, for a meter reading, start from left to right or right to left. This is scale. This is scale. What about this particular minimum or maximum?
Maximum, sir.
For a meter, normal meter. If, for example, it's a 0 to 20 volts meter. What about the 0, left or right?
Left, sir.
So this is 0 and this is 20. Second condition, 0 to 100 milli. So this is 0 and this is 100 milli. So this is. Now so this is for voltmeter. This is for ammeter. Now for ohm meter. What about here? Normally
Opposite,
it's a,
sir. Opposite.
yeah, it's a normal condition. We have 0 here, but in normal condition, always the needle, always that particular needle. For example, this is the scale. Always that needle rests at this particular position without any operation condition. Always which is rests at this particular condition. Whatever it may be that scale. See here, these three are the three. This is for measuring the resistance, this is for voltage, and this is for current. These three. Here this is 0 and here this is 0. But here this is
Infinity, sir.
this is that is infinite. Normal condition remaining for the remaining whatever it may be that which is 0. But for the resistance measurement, that initial condition is infinite. That means here this is infinite. Here this is 0. That means for every meter or for any meter, the reading starts from left to right. But for ohm meter, reading starts from respond.
Right to left.
Yeah, it's a right to left. See here, this is the scale. This is the scale for the ohm meter. See here this direction. So from right side, so this is 0. Left side, which is infinite ohm. That means if it is open, so this is the needle. So initially that needle rests at this position. Of course, here this is the meter. This is the meter, and these two are the patch cords. So here these two are open circuited, rest at this position. If I am short circuited these two, that means connected 1 to 1, then this needle comes to this particular 0. This is nothing but open circuited. So this is nothing but short circuited. Now clear the difference between the scalings of the remaining meters and ohm meters. Clear?
Yes, sir.
Yeah, okay. So this is we are discussed up to now. Why the meter readings from right to left instead of left to right. And see here, this is here we are using two resistors. One is control resistor and another one is zero adjustment resistor, and this is ohm meter. This is ohm meter used to measure resistance, and this is voltmeter. Generally, here one more condition, that is, for example, here I am taking voltmeter, normal voltmeter. It's an analog one. Here in this meter, there is no voltage sources are connected. It's a simple normal voltmeter. There is no voltage sources connected. Later, I am giving voltage to this meter. Now, for measuring this particular voltage, this voltmeter takes its operating voltage from this applied voltage. Now, this voltmeter takes some voltage for its operation, takes voltage from this voltage. అంటే ఈ వోల్టీమీటర్ లో ఇంటర్నల్ గా మనం ఎలాంటి వోల్టేజ్ ని అప్లై చేయకపోయినా దీని ఆపరేషన్ కోసం, ఫర్ ఎగ్జాంపుల్ ఇప్పుడు మల్టీమీటర్ ఉంది, దాన్ని పవర్ ఆన్ చేస్తారు. మీరు పవర్ ఆన్ చేస్తున్నారంటే మీనింగ్ ఏంటి? దానికి ఇంటర్నల్ గా పవర్ ఉన్నట్టా లేనట్టా? Internally, there we are connecting a battery to that meter, and of course we are using panel meters. Panel meters are nothing but ammeter, voltmeter, like that. For them, directly we are giving power. After it shows the 0, 0, which is activated, then we are giving the పవర్ సోర్సెస్ టు దోస్ మీటర్స్. డైరెక్ట్ గా మనకు అవి ఆన్ అయినాయి అని తెలిసిన తర్వాత డైరెక్ట్ గా మనం మెజర్ చేసే క్వాంటిటీని అప్లై చేస్తాం. అలా కాకుండా నార్మల్ మీటర్స్ తీసుకున్నాం. దట్ మీన్స్ ఇన్ దట్ మీటర్ there is no in that meters there is no energies or active energies are available. So we are applying voltage or currents to those meters. Those meters takes the operating voltage from that applied quantity and it measures the applied quantities. That means for its operation it takes energy from the applied quantity, that which with that it deflects and it works. So is this particular, that means how that voltages and currents are taking voltmeters and ammeters, how it takes from the energy sources, is that particular point is clear?
Yes, sir.
Okay, but for this ohm meter, consider here, for example, here this is ohm meter. This ohm meter internally there is no active energy source. Here I am applying some resistance. That means this ohm meter is need to find out the resistance of this applied resistor. So this resistance is not an active energy source. ప్రీవియస్ గా వోల్ట్ మీటర్ లో ఇంటర్నల్ గా వోల్టేజ్ లేకపోయినా ఎక్స్టర్నల్ గా మీరు అప్లై చేసిన వోల్టేజ్ ని యూజ్ చేసుకుని అది ఆపరేట్ అయ్యి ఆ వోల్టేజ్ ని మెజర్ చేసింది. అలానే ఇప్పుడు ఈ ఓమ్ మీటర్ లో ఇంటర్నల్ గా వోల్టేజ్, ఆపరేటింగ్ వోల్టేజ్ లేదు. మీరు ఎక్స్టర్నల్ గా ఒక రెసిస్టెన్స్ కనెక్ట్ చేస్తున్నారు. మీరు అప్లై చేసిన ఈ రెసిస్టెన్స్ లో యాక్టివిటీ సోర్స్ లేదు కాబట్టి మీరు అప్లై చేసిన ఈ ఓమ్ మీటర్ లో యాక్టివ్ ఈ రెసిస్టెన్స్ లో యాక్టివ్ ఎనర్జీ సోర్స్ లేదు కాబట్టి ఆ యాక్టివ్ ఎనర్జీ సోర్స్ లేకపోతే ఈ ఓమ్ మీటర్ అనేది వర్క్ అవ్వదు. అండ్ దట్ మీన్స్ యూ నీడ్ టు వర్క్ డౌన్ దిస్ ఓమ్ మీటర్, యూ మస్ట్ అండ్ షుడ్లీ గివ్ ద active energy source in the meter. Why? Because we are applying here the resistance is not the active energy source. But for previous voltmeters and ammeters, we are applying active energy sources. But this resistance is not active energy source. If you want to measure the resistance, you need to give or must and shouldly give the active energy sources to the meter. So that's why here we are connected voltage. That means this voltage is for to operating this meter. We are not connecting any voltmeter here. So meter అనేది వర్క్ చేయదు, ఎందుకంటే డివైస్ ఆపరేట్ అవ్వాలి అంటే కంపల్సరీగా వోల్ట్మీటర్ కావాలి. ప్రీవియస్ గా మనం యూజ్ చేసిన వోల్ట్మీటర్ కానీ యామ్మీటర్ కానీ వోల్టేజ్ అప్లై చేయకుండా ఆపరేట్ అవుతున్నాయి. ఎలా ఆపరేట్ అవుతున్నాయి అంటే మీరు మెజర్ చేయడానికి అప్లై చేసే క్వాంటిటీ ఉంది కదా, ఇక్కడ వోల్టేజ్ అప్లై చేశారనుకోండి, మీరు అప్లై చేసిన వోల్టేజ్ ని యూజ్ చేసిన ఆపరేట్ అవుతుంది. ఇక్కడ కరెంట్ అప్లై చేశారనుకోండి, దాన్ని యూజ్ చేసిన ఆపరేట్ అవుతుంది. బట్ ఇక్కడ మనం రెసిస్టెన్స్ అప్లై చేసి రెసిస్టెన్స్ ని యూజ్ చేసి ఇది ఆపరేట్ అవ్వదు, ఎందుకని రెసిస్టెన్స్ అనేది యాక్టివ్ ఎనర్జీ సోర్స్ కాదు, ఇట్స్ ఎ ప్యాసివ్ వన్. సో దట్ ఈస్ ద కండిషన్. సో హియర్ we are applying resistance. Based on that resistance, this is ohm meter, it gives the deflection. Regarding that, it gives that. Please note down this diagram and please note down this scale also. Please make it fast. Completed?
Yes, sir.
Okay, ma'am. Now please note down these points also. This is nothing but total current. Half full scale deflection. Total current minus half full scale deflection. So this is previously were defined for voltmeters also. So this is nothing but IM. That's why here I'm not giving one more time. Remaining is the meter principle, which is same as to the voltmeter and ammeters, what we were discussing previously. So these are the things which are available: R1, R2, E, Rn. That E is nothing but there we are connected it as V. R1, R2. R1 is nothing but current limiting resistor. R2 is nothing but zero existing resistor. E is nothing but EMF of internal battery. RM is nothing but internal resistance of D arsenal movement. So these are the things. R1, R2. This is nothing but E, and this is Rn. So these four are. So here we have one assignment like that. So 0 ohm measurement. That means how can we get that 0 ohm from that ohm meter? Anyone? How can we get that 0 ohm from that ohm meter? 0 ohm రావాలంటే ఏం చేయాలి ohm meter లో? So this is ohm meter. This is infinite 0. So these two are the patch cords. Then what should we do for to get 0?
Current maximum flow also.
That means what? What should we do here? From this circuit, what should we do? మనం ఏం చేస్తే ఇక్కడ 0 ఈ నీడిల్ అనేది 0 కి వెళ్తది.
Short circuit, sir.
Yeah, simple. Here if we short circuited these two, automatically it shows that it is 0. So that is, please note down that point. 0 measurement, 0 ohm measurement. When the unknown resistance Rs equals to Rx equals to 0, terminal A and B shorted. The terminal A and B is nothing but those two are patch cords. Maximum current flows through the meter. Under this condition, resistor R2 is adjusted until the basic movement meter indicates full scale deflection IFS. And this is shunt type ohm meter. Shunt type. Simple, just approximation I'm giving you. So this is shunt type. So previously this resistor were connected series, and here we are connected it as parallel to this meter. So this is unknown resistance. Please note down this diagram. Shunt ohm meter. So this is V. So this is our D arsenal movement. Shunt resistor. Please note down that. Completed? Okay, ma. So in this class, we completed 2 topics, that is RF ammeter, and the second one is ohmmeter. In this class, up to now, we completed these 2 topics, RF ammeter and ohmmeter. So it's our today's this hour class. Again, we have 4th hour. In that class also, just I am continuing from the next topic of multimeter. So this is our the lecture for this hour. If you have any doubt among these 2 topics, please ask me now. Any doubts? Any doubts?
No, sir.
Any doubts? So initially, madam given some instructions regarding for the entry of the every class, so which is not related to the morning first hour or afternoon first hour. So for every hour, so you should be in time for the class. Just you have to fix the maximum signal availability, a place in your house. Just you have to restrict it to that place only. కాలేజీకి వచ్చి కాలేజీలో ఎలా అయితే కంప్లీట్ గా క్లాసెస్ లో ఉంటారో, జస్ట్ యూ హ్యావ్ టు ప్రిపేర్ ఫర్ దట్, ప్రిపేర్ just like as that location in your home. Don't mingle with the any other activity. మీలో కొంతమంది మైక్రోఫోన్ ఆన్ చేస్తుంటే మీ ఇంట్లో సౌండ్స్ వినిపిస్తా ఉన్నాయి. For example, now here I am in my home. Here there is no disturbance for you. If I am also having that type of disturbance, it may get some noise for the remaining all of you. So that's why. So it's irritating us. We are not concentrating properly. Even if I am or yourself, we are not concentrating like that. So like that, just you have to fix a particular place where the signal avails maximum and where the noise levels are minimum and interruptions with your family members are less. So like that, just you have to fix some particular place in your home. So just it improves your concentration. So that is the thing. So please be in time to the class. Of course, we have a very less schedule. Very less schedule is nothing but how many days it may continuous, which is not in our hand. So this is only the possibility. So based on that, and of course, this is your last chance for this type of particular platform. In offline method also, I am given this particular instruction. The ముందు మీ క్లాస్ లో కూడా చెప్పాను, ఈ పర్టికులర్ platform, this is final for you. So all of you, please be utilize this particular condition of taking the lecture from the class. Nowhere we are not again repeating this particular condition. ఈ పర్టికులర్ టైం టేబుల్ ఆఫ్ వర్క్ కంప్లీట్ అయిన తర్వాత మీరు మళ్ళీ లెక్చర్ తీసుకోవాలన్నా దట్ ఈస్ నాట్ పాసిబుల్ ఇన్ నార్మల్ వే. సో లైక్ దట్, జస్ట్ యూ హ్యావ్ టు ప్లాన్ అండ్ ట్రై టు ఎగ్జిక్యూట్ దట్ వితౌట్ ఎనీ ఇంటరప్షన్. జనరల్గా పనులు అనేవి లేకుండా ఏముండవు. అండ్ యు ఆర్ నాట్ ద ఎర్నింగ్ పర్సన్ ఇన్ యువర్ హౌస్. In your home, you are not the earning person. That means you don't have any works. So just you have to concentrate on your regular work only. So that's the thing. So, okay, thank you.